We present a method, HiSC 4D, human-centered interaction and 4D scene capture in large-scale space using wearable IMUs and LiDAR. Our goal is to create a digital world containing interacting human motions, large-scale scenes, and rich human scene interactions, without the need for external devices and pre-built maps. IMU-based methods are scene-free but suffers from drifting and is easily affected by metal in the real world. Some methods can capture the interacting human motions but are limited in the lab environment or indoors. Some LiDAR-based methods can capture global motion in the wild yet lack human interaction. To overcome all these challenges, we designed an easy-to-use capturing system, captured multimodal data, and proposed a joint optimization method. Both individuals are equipped with 17 body-attached IMU sensors. The first person also wears a head-mounted LiDAR sensor and a backpack. Let's define 3 coordinate systems. 1. IMU coordinate system, whose origin is at the pelvis joint of the first SMPL model. 2. LiDAR coordinate system, whose origin is at the center of the LiDAR. 3. Global or world coordinate system, which is manually defined in the scene. After data collection, the pre-processing is to acquire the initialized human motions and LiDAR data for optimization. Finally, we relocalize the human motions using LiDAR localization and segmented human point clouds. To address the challenge of optimizing two-sequence human motion in a large scene, we utilize the human point clouds, combined with the scene mesh, as well as the physical cues. For enhanced realism and quicker convergence, we apply a multi-stage optimization approach. In the first stage, we optimize the global translation parameter exclusively. Subsequently, both global translation and global rotation parameters are optimized. Finally, all SMPL parameters are optimized simultaneously. For the V2P constraint, we remove the invisible vertices of the second person from the LiDAR view and resample it to align the LiDAR resolution, which addresses the registration issues for unrigid and incomplete data sources. For research purpose, we present a novel human-centered dataset, which captures 4D interacting human motions and scenes, which spans from 200 to 5,000 square meters. HiSC 4D dataset comprises over 30,000 frames of 8 sequences of multimodal data captured in 4 real-world environments, each showcasing a variety of long-term human motion and interactions, encompassing daily activities, human social interactions, as well as sports. For visualization, we project the SMPL model to the calibrated RGB videos in this sequence. We compare our results with different methods. The method that relies solely on IMU data as baseline 1. The method that cooperates IMU pose data with LiDAR localization as baseline 2. These comparisons also enable the evaluation of the benefits derived from different modalities. We also report the quantitative comparison in the tables. In terms of global localization error, scene plausibility, and smoothness, our method all achieves the best results, which shows our methods only augments pose smoothness, but also greatly improves global pose precision. For the evaluation of our methods, we compare results with ablating loss terms. First, to evaluate the effectiveness of pose optimization, we compare the results with unoptimized poses in the same global localization. As shown in the video, without the extra constraints, the IMU pose is far from realistic due to the misalignment to point clouds. We also show the effectiveness of our self-constraint in helping reduce self-penetration. We report the average runtime and loss of the optimization over every 500 frames in sequence S4. These evaluations highlight the efficacy of our multi-stage optimization strategy. In conclusion, the limitations of our method including the LiDAR's limited vertical FOV and low resolution, as well as the unable running in real time. Our contributions are, introduced a capturing method for human interaction and scenes capturing, proposed a joint optimization framework processing multimodal data for global motions, published a unique dataset containing diverse human motions and interactions. Thanks for watching.